Hello all. Right, okay. Today in this video I'm going to take apart either it's going to be an electronic chessboard or an old clock. So I've done videos before taking things apart. I've already took a few things apart already, like a TV set, I remember a boiler, what else? I took a microwave apart. So I do that so I could see what's inside. I like to know what's inside, how, to get an idea how they work. And I know I'm not an engineer or anything like that, but I just do it at my own sort of leisurely rate, and I just try and make sense of it as to how it works using my own sort of knowledge. And I like to share that with you as well on my YouTube channel. If you haven't seen my videos already, then just letting you know. But if you've seen this sort of video before on my channel, you'll know exactly what I mean. So I've got two things at the moment. I don't know which one to take apart first. I'm going to basically toss the coin, heads or tails, and then I'll let fate decide which one I'm going to take apart. So I'll show you what I've got at the moment anyway. So the electronic chessboard, all this stuff I got from a mate of mine, and he's finished with them, and he was just going to be chucking that out anyway. It's no use, it's taking up space. So he knows that I do videos and donated this stuff to me so I could take them apart and disassemble it right down to its core and just see what's inside and sort of get an idea, figure out how it works, what the bits look like inside, etc. I'll admit I don't know how to play chess. I've never played chess as such, but that's irrelevant to me. All I'm interested in is just opening this up. If that is what's selected with the coin, that is. The other one is this clock. So I'm going to either take that apart, find out what's sort of inside all this, or take the chessboard apart. So I've got a 10 pence piece, heads or tails. I think what I'll do is I'll make the clock heads and the chessboard tails, and I'll toss the coin and I'll see what it lands on. So here goes. It's a little bit difficult filming this at the same time, so I'm afraid that the coin, once I've tossed this coin, it's going to land on the floor. I won't be able to do it like catch it on the back of my hand and do all that because I'm filming. So I'll just have to show you at first hand what it lands on. So here goes. Right, I'll show you. Right. It's landed on heads. You can see that. Right. Heads is the clock. So I'll be taking the clock apart on this video. So I couldn't decide, so as I said, I used this as a means to decide for me. I've got two left and I couldn't really decide which, so I thought I'd do it that way. And I said the clock was heads and the chessboard was tails. So therefore I will be taking the clock apart. I'll do that out the back is, at the back of where I stay. I don't take these things apart in the house for two reasons. Three reasons actually. Firstly, I don't want to make a mess. And secondly, I don't want to disturb others in the house. And thirdly, most importantly, it's more lit up outside. When it's filmed inside and you've got one light source, the shadow is a problem. You don't really get to see inside all the bits and pieces. I mean the clock, well, especially like say, when open up boxy things like TVs or microwaves, because you get a lot of shadow inside. But when I do it outside, it's more uniformly lit because, the sky is much more uniformly lit. So it takes away the shadow problem when I do it that way. So I shall get this up to the back edge. I will get my pasting table out because that's what I do them on. I take them apart on the pasting table. I borrow my dad's toolbox, get any tools I need to either pry things open, because when I'm finished with these things, I just go in the skip anyway. So I'm quite ruthless with them when it comes to opening them up. If something won't open very well, I'll just burst it open. I'll use gentle persuasion, I'll use a hammer and a chisel or whatever there. I'll break it open and get in one way or another as best as I can. Because as I say, they're not getting reassembled to be reused, they're just going at the skip. that's what they were destined for anyway. But my mate said, well, take your pick. If you want to, you know, take some apart, then feel free. I mean, I took some stuff back home. So. Right, I'm going to get on with the clock. And just to show you the clock before I actually take it apart, I'll just have a wee look at it. And I'll spare this chessboard for another video. Okay, right, so at the backs I've got the clock and that in my toolbox, shot my dad's toolbox, and I'm going away to get stuck in about this clock. So as usual, I've got my gloves, in case I cut my hands on anything sharp when I'm dismantling things. So, the first thing I'll do is I'm going to have a look at the back of it. It used to have a pendulum that would have been down here, but that's missing. It's missing when I got it. It's basically just sitting in a pile of stuff ready to go to the skip. And my mate says, well, have a look through some of this junk that's going out and take something that you want to take apart. So I looked at this clock and said, I'll take this along with 3 other items rather. So, having a closer look, it used 2 AA batteries to power it up. All this wood here is just for decoration. So I think I might actually take off the glass plate, the face, the glass face of the clock, and that requires a flat screwdriver. So I've got a small flat, and that will hopefully be sufficient to get these this dress trim. It's like a chrome plated dress trim which is integrated with, the glass is integrated with it. And to remove the glass front, the glass face, I need to take off 4 of these screws, I think. Oh, I'm not counted. It's 4 of them. 4 of them. So I'm going to start doing that now. So off comes the chrome-like ring. There were 4 of these screws. There was a 4th one, which sandwiches the glass. That's the glass face. And then there's another dress ring. So these 4 screws hold all this assembly together, and sandwiched between these 2 is the glass face of the clock. This is the paper that I painted on, I think. Oh, is it? No, it's not actually. It's oh, right, it just lifts off. Jeez, that's it. So it's just like a bit of card with this here, which is just to sort of prevent any vibration, that kind of cushioning. It's not adhesive, that's stuck on the other side, isn't it? It's just like a dampener. And this whole assembly comes out, and then you just, all this here is just the wood, the wooden dress. This is probably the most expensive bit. I think when the pendulum was on, which would have locked off this mechanism. I'll get into the guts of this shortly. I don't even know. I'll see if I could dig out the battery, and then if I've got batteries, if it's still working, I could maybe demonstrate it working. I'm going to have a look. I actually felt quite sad when I was loading that clock up into my car, because when I was doing that, I says to myself, that'll be the last time that clock will see it'll ever be in this state, because when I'm finished with it, it'll be in bits. And it, you know, I was just thinking that. I said, well, it sat in my, and it sat there stored for a while, and today's it's destined for its final destiny. It's going to be totally taken apart. I don't know how old it is. I never owned it as the same. It's probably been, I don't know how old it is, like. But yeah, I was putting it into the boot and I thought, that's it. It's numbers up. It's time's up. All pro play, all fitting. Time's up, and it's a clock. But yeah, sort of felt a wee bit sentimental. But even though I haven't owned it, it's just sort of like, you know, some bits already. Anyway, I'm going to get a battery, a couple of batteries. I'm going to try and get a couple of AA batteries if there's any floating a bit in the house, and see if we could power it up and see if this show this pendulum thing working as well. So I've got some AA's. I'm going to see if we could switch this on. Well, the pins are all buggered for the battery contacts. I mean, I've got this one the right way, clearly. Positive, negative on there, which is right. And there's no any insulation on the batteries. And then on the other one there's a contact missing or damaged or something. Doesn't even tell you what the other side is. I could see anyway. I put the batteries in. I put them in and it's not working. Hardly surprising. Probably the reason why it was thrown out in the first place. So I've tried it this way. Switch that on as a switch. Switch the clock on. Ah! We have something. I could hear ticking. You might hear it. There is something working. Yep, there is something on it. So I was messing about with the terminals and I got power to it. I could very faintly hear the ticking inside. I don't think the pendulum bit's working. I'll put the microphone right up against the device so you could hear it. Right up against it. I think what side the microphone's on now. Very faintly you could hear it ticking, but there isn't any movement on the, or is there? On the pendulum. Let's just sit it like that for a minute. Yeah, pendulum bit's totally knackered. That's just actually the wind that's making it move. There's no any. There is power going to it though. The mechanism is actually working, but I was hoping to see the pendulum thing working, but that's just for setting the actual time. This device, turning that, it's just for adjusting the hands, adjusting the time. I don't feel any resistance or anything. So I'm going to take the batteries out again and I'm going to just take this thing apart. So to get into this device, into this mechanism, first of all I'm going to take off the batteries are removed now. And I'm going to take the hands off. And to do that, I think this brass thing here, what's underneath that? It's under that, it's behind there. Just figure out how to get them off now. What I've done is I've got myself a pair of these needle-nosed pliers and I've put them on here and I've turned it anti-clockwise to slacken this. It seems to be doing something. So it's difficult to do this at the same time because I'm hiding the camera. So what I'm doing is holding the arms, the clock hands, and holding the clock hands stationary well and then slackening this, locking up. I don't know why I called them arms, these are the clock hands. I don't know what I was thinking of calling these arms, these are clock hands. So, I've removed the clock hand That's the minute one. This is the other one that seems to be splined on. Is there some sort of circlip? Oh no. I just press. It just goes on like that. I think it locks it on now. I think that flat bit there must. Ah, yeah, that's how it is, because that's flat. So that then basically stops it from turning on the, spinning on the actual shaft. It locks it to the shaft. So the hands could turn with the shaft rather than the shaft turning through them. Because if it's not locked on, if there isn't that flat there to make that flat, that will just spin, the hands will just spin. That won't actually make, you know, the shaft will spin, but the hands will just sort of remain stationary. It needs to be locked with the flat on there meets the flat on the shaft, which kind of locks it, prevents it from spinning, from the shaft in relation to the shaft. So in other words, it turns it with the shaft. It keeps it from like the shaft spinning within the hand, the clock hand. So that's the hands removed, and it's absolutely burning today. I have to give in. Normally I film with the hat on and hide the grey hairs when the sun's beating down. It just makes me feel older than I already am. I'm 49 this year, a couple of months. And then I'm just going to have to go out the house and change this. I'm going to take this off and put my light shirt on because the sun is beating down. It's absolutely melting. I was hoping to manage this without that. We haven't got a bottle of juice in that to keep us cool. Right, I'm going to have to go and do that now. I had to cool off for a wee bit. It was also melting out there. It's quite hot. Can't complain though, the weather's really nice. Right, let's get back on with the task at hand. My top and a shirt put on instead, because it was a wee bit cooler earlier, but it's got really, really hot now. So, right, where was I? So this mechanism here, this basically runs right through into this motor mechanism. I'm going to find a way of getting this collar, or whatever they call it, this locking collar off. So it seems to me that this clock face is basically bonded to this bit of wood. And this wood here is sandwiched between the mechanism and the clock face. And to get the clock face off of, get this all apart, this brass thing here is going to have to come off somehow to allow this shaft to come right out, because that shaft's fixed to the mechanism, and I want to get the mechanism off this clock face. Whether it's, I don't think it's serviceable, I'm not sure, but I don't know how I'm going to get that off. It looks like there's a thread on there. There's a thread on there that perhaps this would come off of, so I'm going to see if I could figure out that. I don't have the proper tools, but what I've done is I used this flat screwdriver and hammer, and I just basically tapped the the screwdriver with the hammer and put the flat of the screwdriver into this bit here, and then hit the head of the screwdriver with the hammer to slacken it off anti-clockwise. And it seems to have done the trick, because it's slackened it. But it's difficult to do this at the same time as filming, but it's coming off. It's coming off. I could see that. There we go. So this whole locking tab thing is now removed. You can see it's threaded, which will now allow the clock face to come off, which it has done, and that's like a wee washer. This bit of wood was sandwiched between the clock face and the mechanism. Now this is the actual mechanism itself, and there's a capacitor, a couple of capacitors, a wee transistor there, resistor as well. So there's capacitors, transistor, and also a resistor. So there's a resistor, transistor, capacitor, and bigger capacitor. And that's the printed circuit, or the circuit board. And there's a wire from the battery terminals going to this. And there is a switch here as well. And yes, so now that I've got the mechanism off, I'm going to figure out how to open this up. I don't think this is serviceable, meaning it's sealed for life, so the only way to get into it is to break into it. So I'm going to have to do that. But before I do, look, this is the pendulum. It's difficult doing this as well, but I'm doing my best. The pendulum, that bit there, fits into the mechanism that runs to the pendulum. You could kind of see how it goes together. So this will be the bit that moves. That will get energised. That bit there will get power applied to it by somehow. I don't know how it's done it, but that then just relays the power to this bit, which relays the power to the actual pendulum, and then the bottom bit that's missing, which would have came down. So basically the pendulum would have been like that. So you can imagine that as a pendulum. But the pendulum bit's missing, so it would have went like that. That's this pendulum bit. I'm just using the hammer as an example. That would have been connected to this, which is connected to, try and get somewhere where there isn't too much shadow. Getting the shadows right, so it's connected to that, which in turn is getting this torque and movement through this triangle bit. It's just too much light with shadow. Anyway, I've got to now figure out how to get into this. To get into that, I'm afraid I'm just going to have to, I've had a look at it, it looks like I'm going to just have to pry into it and burst the plastic. I have to break into it because it's sealed for life. In other words, it's non-serviceable. So I'll use, I'll go and dig something at the toolbox to fulfill that task. I've actually just enlisted the help of that flat screwdriver, and that was able to pry out the circuit board, which does reveal something on the other side. I think it's coil. I don't know what that is. No, my dad's busy at the moment. I don't want to have to bring him down just now to ask him to. I'm not going to disturb him. He's in the middle of doing something at the moment. So I'm just going to have to just wonder what the heck that is. What the heck is that? The silver bit. I'm really intrigued what that is. I'm going to have to disturb my dad, I'm afraid. I'm going to have to ask him to tell me what that is, because I want to know what that component is. It's really bugging me now. So I'm going to have to go and ask my dad. Disturb him having his lunch. But no, I know what it is now. It is an electromagnet. It's for the pendulum. So the pendulum bit, the mechanism on the pendulum, has got a magnet on it as well. And when this electromagnet, which is this here, when that energises, it pulls the magnet on the pendulum mechanism towards it. And then once it's time for it to release the for the pendulum to go back, it de-energises it. And then therefore that is no longer an it's no longer a magnet when it's been de-energised. And it allows the pendulum to swing back. And once the momentum will then cause it to swing back towards the the opposite way, and then once this electromagnet is now energised again, it then pulls the magnet back over to allow the pendulum for this motion. I'll show you this better. Basically I was trying to explain the electromagnet, which is this here. So when power's applied to it, it becomes magnetised. And on the actual mechanism, for the pendulum arm, there's a magnet there it is. Just there, you can actually see it, magnetic. It's holding this, you can see it. It's holding a screwdriver. There, sort of demonstrate. That is the magnet. That's the magnet there. There was a bit of shadow because of the way the light, the sun's, but that's the magnet. So when this electromagnet is energised, when the transistor, you know, because this little circuit here is a timer circuit, which will be like energise and de-energise, energise and de-energise. And when it energises it, it attracts this magnet over towards it to swing that way. And when it de-energises, the momentum, because it's either spring loaded or something, it will go back that way. And then it will energise again, and then it will do de-energise, energise and de-energise, and that will cause the pendulum motion. I'm not an electrical engineer and just try my best to explain it the way that I explain it, so hopefully it makes some kind of a sense to you, gives you a very, very rough idea, but at least I know what that component is now. It's an electromagnet and it's for the pendulum mechanism. It energises, it sucks the pendulum that way, with the pendulum arm's got the magnet, the permanent magnet on it, sucks it that way, or magnetises it, attracts it that way. And when it de-energises, because it's like this, it'll de-energise, it'll swing the opposite way, and then when it goes energises again, it'll swing back, and that's the pendulum motion. Best I could do it. I'm not a teacher, I'm not an electrical engineer, but Dad's an electrician, he's an electrical engineer, he knows, but he's he won't come, he's busy and he's having his dinner, so I've just got to explain it the best I can. That is that. Now I know what that is. Now, the next task is to remove the pendulum arm from the rest of this mechanism. I want to do that, so in order to do that, it looks like there isn't really any way, because this tab there's no any other way without breaking it, because that prevents it from coming off at that side, and that prevents it from coming off at this side. So the only way to get that arm off, because it's a non-serviceable part, you can see how it fits on. You can see just where it's latched in. There's no really any way for it to come off without breaking this part off to allow it to come off. So I'm going to be able to do just that. Because it's relatively soft plastic, it didn't actually break, it just kind of like gave way. It kind of like flexed to allow this to come off. So this is the pendulum arm off, and there's a closer look at that magnet, permanent magnet. As you can see, that only becomes a magnet when it's energised. Now, maybe I could put a battery in and see if it will actually energise, eh? I'm going to do that now. The battery's in, it's switched on. I can hear the ticking, so there is power going to it. I haven't broke any of the electrical stuff yet, so there's power going to it. So I'm going to check to see if that electromagnet is acting as a magnet. So, let's see, shall we? No, it doesn't seem to be much going on. No. Nothing. That one's no bother, it's a permanent magnet. But this isn't. Nothing. That's probably why it was thrown out. I don't think there's anything anyway. It sure doesn't feel like there's very much. Let's just try something a bit lighter. First of all, I don't think these screws are, unless they're just chrome plated. I see they've actually made a chrome or whatever, so they won't work. This definitely is a magnet. There's nothing there. I can't feel any resistance or anything at all. So as far as I can see, there's nothing. So the magnets, there's nothing there, nothing at all. Oh, the sweat's pouring off me. It's really hot now. I'm not complaining. I either complain it's too hot, or it's raining, or it's too cold. No, I know this time I'm going to enjoy it. It's hot, it is, but very seldom do we get good hot weather in Scotland, in Dundee. When you do get it, it's rare, so I'm making the most of it. Anyway, this actual mechanism is probably fairly standard. This bit here in the centre, that could be seen in small portable clocks and everything, because it's just probably a fairly standard part. That's really all there is to it. It's just to turn the clock hands. This will be like more custom for the clock, the specific clock. and all this plastic shrouding around it, and the pendulum bit. But the actual clock mechanism, electronics, this whole sort of rectangular assembly in there with the wee dial at the top, all this would be probably standard or fit in quite a lot of other small much smaller portable clocks. So I'm going to get into this. I'm going to get this out of here, this whole assembly bit, out of this plastic shrouding, because this is more tailor fitted for the Pacific designer clock. That's the next task I'm going to do. Just saying, all this here is just mainly standard for probably most cheap clocks. So it's got quartz in it. So I'm going to somehow get this out. This is now, it's a non-serviceable part, so it looks like I'm going to have to just kind of like break this out of all of this. This is all tailor fitted, this plastic bit's all tailor fitted for this specific clock. But this bit here could probably be standard for quite others because it's quite a small setup, and the shaft just runs right through to the mechanism, which I'm going to have a look in and see the wee gears and everything in there. I've never assembled or reassembled these things before, but there is a way that it comes out. From the back it seems to just be kind of like little latches and clips and that this whole assembly comes out. So it fits in there. I think these wee locking tabs have something to do with it. So I mean, maybe this bit here could be serviced, you know, this whole bit here, this could come out as a unit and maybe be replaced perhaps, but I don't think you could actually get into here to replace anything. I think this is all sealed. But the actual, this is more this bit here, this plastic assembly is more tailor fitted for this designer clock, whereas this assembly, although this big long extension of bit here is, again, that's tailor fitted for this clock because it's got to reach through the board and everything. This board that's sandwiched between the clock face and the mechanism, there's got to be enough length for it to make contact with the hands, because the hands basically just go on to the here. That's the other hand I put in, or is that the minute hand, sorry. But yeah, that's what I was saying earlier, this fits on like that, and then there's a little washer that clamps this, that must be a fixture, so it stops it from spinning on the shaft. So it doesn't spin on the shaft, it spins with the shaft, because it's got these flats there that prevent the hand spinning on the shaft. These flats meet up with the flats on the hand, which makes the hand spin with the shaft. If that makes any sense. So I'm going to break into the casing now. I'm going to get this top cover off, and I'm going to see all the wee gears and everything inside there that makes the actual mechanism turn. This, by the way, is the bit that turns. There's like an inner, that's the inner shaft, that's the bit that turns. This here is just the threaded bit that just basically does acting like not like a spindle, but an outer shaft, but it doesn't. That's just where everything's fixed onto, like the locking washer and the hands and everything. Well, the hands fit onto the inner shaft, but this is like a hub, if you like. That bit doesn't spin. It's this bit here that spins with the, you know, that for your clock hands. So I'm going to whip this top cover off here. Myself in a small shaded area, and I wasn't able to see it because of the light, the way it was shining on it. That's my excuse anyway. But this looks like it's kind of allowing this plastic bit to come off without actually snapping off or breaking off. This locking tab kind of goes over. That has to be lifted. This plastic bit here has to lift over that locking tab in order to get this cover off. And there'll probably be one on the other side. Yeah, there is. So I'm going to try doing that first. Now let me tell you something. That locking tab took a little bit of persuasion with the help of this flat screwdriver, and when I kind of like maybe put a bit too much pressure on it, the thing went flying. It went right past my head and went way over there. So that's why you really, if you're messing around with things like that, my dad always says you should wear like proper goggles and gloves and all that stuff, just to, you know, because that bit did go flying. It kind of snapped up and flew up, went away over there. It went past my face. It could have hit my eye, but you gotta be careful. But anyway, I've got into it. I'll show you a bit clearer what I've done yet. So, like I said, that Now a wee gear came flying out as well. That fits in there. Now this is like the delicate bits, the intricacies, the guts of it basically, the gubbins, right? All the wee bits and pieces. This is the main part of the whole thing. This is what makes it work. This is it. This is the main deal. That's where all the magic happens, if you like. All the rest is just for, you know, decoration and just for show and stuff, but this is the actual business end of it. And you can see just how intricate that it is. There is transistors, a wee circuit board, and there's this electric coil as well. Now there's quartz in here. Now this is just, as soon as I turn this upside down, so all bits are going to go flying. Yeah, that is. So don't ask me to reassemble that because I haven't got a clue how it all assembles. But there's just, I mean, unfortunately, when I took this cover off, that tab on the other side went flying, and I went past my face and went way over there, and you know, I just gave it a wee bit of leverage with this, like, yeah, and it just kind of snapped right off and punged right up and nearly hit us in the face. I don't have the right tools for this, but so you've got all these wee gears, and it's pretty well engineered, like. I mean, I don't know just how all this goes together, but it reminds me of what's inside an automatic transmission, I guess. Planetary gears and whatnot. I mean, this is, I don't know, it was in a minute, it's very good. It's all gear ratioed, basically. It's all gear ratios. It's to do with the speed of one gear going around it. Time it takes exactly a minute for one revolution of the, you know, the second hand. It's just all gear ratios. I don't know, I wouldn't be able to explain it all. Unfortunately, the whole thing's just completely and utterly disintegrated now. But these things are all machine, well, be mass produced. It'll be a production line where all the bits will just be assembled into. I don't know where the quartz is in here. Ah, quartz crystal. There's like this runner. So I might have to go and ask my dad, find out where the quartz is in here. Yeah, it looks like I'm going to have to bother my dad again. I want to know where the quartz is. Like you say, all these small parts are, they'll be assembled with an assembly, and there'll be like a belt. I mean, it's going back, 25 years ago I worked in a factory, done electronic stuff, telecommunication stuff, and it was just a long belt, and wee things like that, the belt goes along slowly, you just insert the bits that you put in, then it continues along the belt, and then other workers up there will just insert their bits, and it's assembled like that, and it's just continually a conveyor belt, and he's just putting the same bits in at your workstation. All the workstations have got their own parts to put in, and it's done in a long conveyor belt. And by the time it gets to the end of the conveyor belt, the assembly's like nearly complete. There's obviously other things to do, but that part will be complete. So it starts at the bottom of the assembly, just a flat circuit board, similar to that, I guess, and then they'll just add bits on as it goes along the assembly and mass produce it that way. I couldn't imagine one person just assembling all that, by hand with himself. It's all done for mass production, for save time and cheapness and that. But it's very intricate. You probably need tweezers and precision screws, precision parts and tools to do that kind of work, because these bits are tiny. So they'll be all mass produced parts, and they'll be put down in a conveyor belt. I don't know how it's done. I don't work in a factory. I'm just guessing it'll be something probably along those lines. That's a very rough idea. It'll be mass produced because it's cheap. It's just a cheap clock. So, but I'm going to wait, ask my dad again. I'm going to bother him again. I'm going to ask him to find out where the quartz is, because I think they use the quartz as I don't know how it works. It's very accurate Oh jeez, I don't even have to get my dad gives a rough idea how that works, how the quartz actually works, where it is and what it does. But it keeps the time accurate anyway. Something like that. I wouldn't bother my dad again. Right, so Dad helped us out again. The quartz bit is there. That's the quartz component, and that vibrates at a set frequency, a very accurately set frequency. And from that, they set the clock time with. So in other words, you can set your clock back quite literally, because the frequency is very accurate. So when you apply power to it and whatnot, it vibrates at an exact set frequency of which you can then time the clock circuitry off of in order to keep the time accurate, because this is always going to vibrate at a set frequency, and that's the quartz bit there. It's a very rough idea from me as to how to explain it. I'll try and get a better view of it for you. You can see the sun's moving over that way a bit now, so I'm getting a wee bit more of a shade, which is nice and cool, and it makes it a bit easier to. So you could. Come on, I forgot to do bring the magnifying glass down, but I don't really need to because I can just zoom in with this, can't I? So, because I was looking at it through the magnifying glass earlier. And this, as I said, if I could line this up at the same time, that's the quartz component there, and this. It's obviously inside there. I might break that open later. I might actually break into that. This. And see if you could actually see the quartz, see what's inside it. But there's a microchip as well, very finely. That black thing there, I'll just break off, I'll just pull off. There's not much there. That's, I think, what. No, I know what this coil of wire is for. That's the electromotor. That's obviously. I think. This here will be what causes the motion. Now I don't actually know how this works. My dad would be able to explain, but he's totally busy at the moment. But this coil will be what energises, in a nutshell, that's what will make the hands on the clock turn. It'll go through the mechanism, all these gears. There'll be probably a lock-up, one-way clutch or whatever, I don't know how it all works. But this will be responsible for the movement. Now the tick sound must be something to do with this, with all these gears. There must be kind of like a. How it works, I don't know. I can't explain it, but you can see it's all complex. I don't go into it in depth. I just show you what's inside it, and then you just make what you want from it. But somehow, anyway, I do know from my knowledge that is like it'll energise, it'll cause something to rotate every second. It'll go like, it'll pulse every second, and it'll cause one of the gears to turn like 1 second, 2 second, 3 second, 4 second. And as it does this, it'll work through all this gear mechanism. It's like gear ratios, which will be in relation to the time. So you've got a minute hand and the hour hand. So this will obviously go 60 times faster than the hour hand. So the gear ratio will be 1 in 60 or something like that. And as I say, this quartz bit here will set the foundation frequency of which you could then set up and calibrate the rest of the circuits from, to allow an accurate speed synchronization. And the gearing will just be like a reduction gear, so this will go 60 times slower than it'll take an hour for it to go round, whereas your minute hand, well, that'll take 12 hours, won't it? And all over the place at the moment. You've got your second hand, it'll take obviously 60 seconds to do a complete circuit, and the minute hand will take an hour to do a complete circuit, and that'll be like your 12 hours. So it's gear ratio down, and now these gear reductions will be done using these gears, so effectively there'll be more torque in the other hand then, because energy is torque times speed, so there'll be 60 times more torque. There'll be more torque in the, or 12 times or whatever, I'm all over the place at the moment, but the faster it spins the less torque, and the slower it spins the more torque. So in a way you can think of it that way as well, just like a gearbox on a car. So there's a close-up look at the circuits, and my dad was saying that'll be the microprocessor or something there, that bit there. So I'm assuming then, as I said, that I must set up a frequency, that'll pulse this electric coil with a timed frequency. It'll be in phase with, it'll be in time with this frequency. Will set the base. That will calibrate everything from because this will vibrate at an accurate frequency. So they could use that accurate frequency to calibrate the rest of the timing circuit. And I'm guessing it'll just pulse this, set up a pulse in here or whatever that'll energise this, every second it'll energise, which causes one of these gears to move once, and then the rest, in turn, the gears, because they're of reduction in speed, they'll move in correspondence to the minutes, the seconds, minutes and hours. The ticking sound must be something in here. I don't know what would cause the ticking sound. It'll be one of these things anyway. And you've got all this stuff as well, so. And that's the adjuster, the manual adjuster, which obviously it's got a gear bit on the end of it, like a spline, well not a spline, well a gear that will mate up with one of these gears. This is like a gear carrier then, this complex, it's like acrylic. That'll be the gear carrier, all fit together, all work in harmony, so it tells you the time basically. And these are making contact. I'm not quite sure just what all these bits do, but now, like I promised, I'm going to take this quartz bit off. I'm going to just break it off and break into it and see what it's like in there. See, I'm no engineer, I'm no electrical engineer, I'm not a mechanic, I'm not a clock builder or anything like that. So I'm just guessing. Like I say, this video is only for entertainment purposes only, it's not to be for quotation, don't quote me on anything on there. It's just for viewing and entertainment purposes, so like I say, don't quote me on anything on this. Like I say, if you're doing shit like this, be careful what you're doing. Wear gloves and goggles because they're sharp bits. Like I said, the tabs and that, I broke a tab off, it went flying, it went past my face, could hit me in the eye, so you got to be careful. In case things hit you in the eye. If you're not doing it properly, I'm just breaking into things, but if you're professional and you've got all the right tools and stuff, then you could do that. I don't have any of that, I just do it all the backies out the ear, and just break into it and see what's inside, and I'll just give you my understanding of how it works. And that's what the video is about. I say, don't quote me on the stuff on it. So, I'm going to get this off the circuit board, this quartz, and I'm going to break into it just by probably squeezing it with the pliers or something. I'll get into it somehow. So I've wrenched it off the board and the legs have came off, so it nearly ran away. I'm going to need to break into this somehow. I'll go and look at the toolbox and see what I could use from here. Probably a wee hacksaw, and then I'll burst into this and see if I can see any like quartz or anything in there. So I tried to hacksaw it. What I did is I held it with the needle nose pliers, then I used a small junior hacksaw to try and hacksaw into it. That didn't work very well, kept moving in here. So I'm going to now resort to these snips, and I'm going to burst it open with snips. Snips, initially it just basically crimped it and just sealed it, so I had to then reopen it with the pliers just to, because it was like that. It's, when I crimped it with the snips, basically just crimped it. But then I used the pliers to, open it back into shape, like such. And that's the both halves there, well, not really halves, that's the bigger bit. I'll put a light on it, see if I could see what's inside it. Now it's easier for me actually just to look through the screen and zoom in, rather than try and use my naked eye. It comes in quite useful. I reversed there, try again, I was doing it again. Come on, there we go. I try to keep a steady hand as well, it's not easy. Not so easy. But that's in there and that's what's inside that one. Now I don't know what's what, but I don't know what the quartz, it's a crystal, isn't it? So I've turned it upside down, I've even, see if I could shake anything out. Nothing really seems to be coming out, not much happening. Doesn't seem to be an awful lot in it, to be honest. Doesn't seem to be much in it. That's the closed end where the legs went in. See if we could crimp it further open, see if we could open it further. So, there. So I'm trying to zoom in without it going out of focus, but it's not really, it doesn't seem to be very much specific to see. It just, I don't really know what I'm looking at in there, to be honest with you. Like, keep zooming right in, like that's a bit annoying. I wish it would stop doing that. Come on, now the wind's blowing that way. Try again. For goodness sake, camera. Third time lucky. Try again. I wish this would stop doing that. It keeps going to give up. Right, well that's it. I don't again. That's really all I can do. There doesn't seem to be very much going on in there, to be honest. It's just nothing much really. I tried my best to film it, but I don't know. Not much in there. There's a pain in the neck to get. I don't have all the Pacific tools and stuff. I don't know how the quartz looks as a crystal, but I opened it up and showed you what's inside as best I could, and that, there you go. So there isn't really much more. The coil, this is just a coil that will go into a core, like an iron core, and that will energise. That will be what's responsible for, act like an electromagnet, I guess. It might actually be what's, I might use these levers perhaps to move the gears, I don't know, but it's all intricate and complex anyway. But you can see how complex it is. It's not like there's a million parts, there's just some important gears and stuff in it. This will be like a flywheel, I guess. I don't know, some sort of... This could be what's responsible for the seconds, the actual knocking sound, because that was just like floating when I was floating on a shaft before it all came apart, and I think that might have something to do. It might be like a ratchet. Every now and again it'll move like a ratchet along these gears, move it in 1 second every second, which will move the gear a certain amount, which will move the other gears a certain amount in relation to its gear ratio, which will eventually give you the time ratio. These are just made out of plastic, acrylic, all this stuff. I don't know what plastic that, composite plastic that's made out, but this is just kind of like a clear, light plastic. It's kind of metalish. There'll be a core on there. There's not much to see in there. I mean, I could snap open a microchip, but there's no really, I suppose I could take the what do you call it, snips, and probably snip right through the centre of the microchip, see if anything exciting's in there, see if we could zoom in. I'll go and do that now, I suppose. Once again, I use the snips, and because I apply a lot of pressure, when you use snips, by the way, that's the mechanical leverage effect. All that effort, all this motion from this end, from the handle, all that movement there, right, all that is being concentrated onto these very small bits. So all the effort you put in with your hand is putting a tremendous pressure, mechanical pressure, leverage on the hardened ends. We probably, I don't know, diamond tipped or whatever, on the ends of these, and that gives you the biting pressure that bites into stuff. And when it did that, because it's a hard material, again, it went flying. it actually snapped in half and it went flying. So if you're messing about doing stuff like that, my dad's right, you know, you should wear goggles, because that could have hit me in the face, it could hit me in the eye, because you're putting a lot of pressure when you're snipping something like that. You get a crack. It's all the leverage, all this motion you're using with your hand on the handles of the snips, all that movement, right? I don't know, 3 feet, 3 inches, 4 inches, maybe 6 inches, I don't know. You can see it, all that has been concentrated on the smaller movement on there. So all that effort, and it's a small part, so it's concentrating all your hand energy, muscle movement on that's going through this mechanical pivot point has been concentrated on these tips, and that's what gives it the pressure to bite into stuff. It's very sharp, but concentrates a lot of pressure into something, and that's the cutting edge that allows the snips. I use snips, it's brutal because I just wanted to break into it to see what's inside it. The whole thing's finished anyway, it's going into the skip, so I might as well learn from it before it goes through it. So I snapped into the circuit board, into the microchip, and not a lot to see. I'll zoom in better. But yeah, that bit there went flying because of the mechanical pressure that's been concentrated onto it. That's what ultimately breaks into it. So I've broke into the centre of the microchip. That's one of the halves. That one part of it's not really half, but that's one part, and that's the other. That's the bigger bit that's left. So it just looks like plastic. I mean, it's micro, so you're not going to really see much unless it's under a microscope. But that's looking into right through the centre of it anyway. Of the dad reckons that's the microchip. There's a lot of contacts and stuff going in and out of it. There was before I broke it. You can see, like on the other bit, the other half, all the contacts. See all these contacts that are leaning into this chip. So it seems to be doing a lot of decision making. You know, there's a lot of stuff going in. It's like the epicenter. It's like the brain of it, if you like. It's the main part of it, and the microchips. That's the brain, if you like. And I've just snapped right through the centre of it using the snips, and this is what you can see. It just seems like moulded plastic, nothing really to look at. There is a wee bit of like stuff there, this discoloration, and it seems to be correspondent on the other bit, which is trying to run away from me. Just stay there and I won't balance up, will it? Yeah, there we go. So that white bit, and there's a white bit there. There's a white bit there and a white bit there. I don't know if that's got anything to do with anything. Maybe it's just stainage or something, I don't know. I don't think there'd be any room for stains inside a microchip. There must be a purpose for it. But anyway, I think that's going to have to do. That's pretty much it. There isn't really much more to this clock. There is this electro coil, but sort of coating on there, it could peel off, I guess. No, I'll cut my hand off. Great. That's why I should be wearing my gloves, eh? I just couldn't be bothered wearing them, so as a result, I nearly cut my hand. But anyway, this is a coil, electro coil. That's responsible for the pendulum to energise. Well, this energises into an electromagnet. But this becomes an electromagnet when it's energised, which pulls this magnet on the pendulum arm towards it. It attracts. Magnets attract. If it's the right way, they'll repel if it's north and north. If it's north and south pole, you know, they attract. They can repel or attract, depending on what polarity you set your magnet at. But in this case, it will suck this magnet. It will attract the magnet across. When it becomes energised, which will pull the pendulum that way, and when it de-energises, because it's sitting at that angle, it will release, and then it will swing that way, and then it energises again, it will swing, it will be attracted back to the electric coil. I think that's the best I could do to understand it. And there's the wee circuitries that control that, and the timer, thyristor, transistor, the black component there that'll be responsible for the time delay for the pendulum. I don't know if it's in sync with the second hands or not. It depends on how accurate the clock is. It's a fairly cheap clock. So what I'm going to do now is I'm going to get all the bits and pieces of this clock. I'm going to put them on the table in a nice orderly fashion, and then I'm going to take some photo stills and just video them all individually. So I'm going to get this all laid out into a nice neat pile now, into nice orderly fashions. The components in there in a orderly fashion, so I could show you them all individually and photograph them all. So I shall do that now. And before I done that, the curiosity got the better of me. I decided to snip open the capacitor. Now I would never advise anybody to do it because capacitors could be potentially deadly, but because this only operates on battery power, the voltages in there are going to be relatively non-lethal because it's only battery operated. But it's not a good idea to mess around with capacitors because these do store charge, electrical charge. That's its whole purpose. But like you see, the voltages in this is small, so I just burst it open with snips. Once again, the other half went flying and you're going to, oh no, there it is, it's on the ground, I find it. Yeah, picked it up, it was on the deck. So I'll get this wee screwdriver to point the bits. That's inside the bit that I just picked up, that's the capacitor. There's this sort of like paste or whatever it is. And inside this the other half, which is on the board, there's like a kind of, I don't know, like a pasty kind of stuff. And then there's this sort of silver, it's plates, it's like foil, and they wrap them around there, and then it stores charge within them. Stores electrical charge, but that's inside the capacitor bit. It's like a kind of foil, and probably a like insulation paste or something, I don't know. But I just thought I'd snap in it anyway. There was nothing else to open up, so I said I might as well just open up a capacitor before I start putting things in a nice neat orderly fashion on the table. Get all the destruction stuff done first before It's maybe not a good idea to handle that shit in there. I don't know what it does to you. It's maybe not a good idea to touch it, but anyway, that's what's left of this. It's measured in picofarads capacitor, but I just thought I'd burst it. I suppose while in it, I might as well break into the resistor as well, and also the other capacitor. So I'll go and do that now before I put this in a neat orderly fashion. Others as well. Now I did have the good sense to close my eyes while I was snapping them with the snips. At least I had done that right. I closed my eyes. I didn't wear goggles, but at least I closed my eyes. So the bits went flying again as usual. Only surprising what pressure it goes onto them when you're using snips. But there's inside the transistor. It's just moulded plastic. There's like an electrode in there. There's inside a resistor, which is carbon. It's resists the current. I think it's carbon anyway. That black core in there, and it's colour coded, which gives you the value of the resistor. And there's this like flatter capacitor that was flat originally and it's snapped into it. It was always flat. It's not because I flattened it, it's flat because it was made that way. And sandwiched there is this black stuff. So this is the round capacitor that I opened up again after snipping open, and there's like two electrodes or plates in there. There'll be one set of charge around the foil or something, and then the other end will be in the, well, I don't know, essentially, I don't know exactly how it works, but I've snapped into them anyway. And there's a capacitor, transistor, three-legged transistor, resistor, so transistor, resistor, which impedes the flow of electricity using like a, I don't know, carbon, I don't know what that is, a resistive material anyway. And there's the other capacitor. So I'm going to do what I promised to do. I'm going to get them and put into a nice neat pile now. Right, I've got them in sort of a bit of an order. Oh, first of all, this pendulum mechanism, all the actual pendulum bit's missing. I never got that with the clock. That was gone already. But this was what the pendulum bit would have fitted to. This bottom bit. That's the bit that fits to the actual mechanism over there. So that's the pendulum arm bit. This is just dress wood. This is just, I don't know, mahogany or something, varnished mahogany. Maybe not even that. I think it's a cheap, just wood of some sort. It's been, I don't know what type wood it is, but it is wood. I don't think it's chipboard. I don't really know. I don't really care. It doesn't really matter. I was only finding out. I was snipping it out a little bit. Just find out if it's chipboard. I don't think it is. break a bit off and we'll find out, eh? Nah, I think that's mahogany. Yeah, mahogany. So, well, it's wood anyway, it's not just chip. It's not like this stuff, this is chipboard. This is used as a spacer between the clock face and the mechanism. This was sandwiched between the mechanism and the back of the clock face, this bit of wood. And through the centre here, the main drive shaft, if you like, that's like the hub bit. And this bit goes through it. Other way around actually. So this goes through there. And the clock face went obviously on the other side like. But this was just a spacing block anyway. So this might be the main drive. So that's the wood bit. Done that. That's the glass face. The actual glass. Probably one of the most expensive bits. It's like brass fittings, brass locking nut, and that's also polished brass because it's on the clock face side. This is the bit that will be seen, so they make it look, you know, a bit more attractive to fit in with the rest of the design. And this is the main, obviously self-explanatory, that's the main clock face in Roman numerals. That's the hour hand, that's the minute hand, which has got the flat bit. It meets up with the flat on the drive shaft, so that it doesn't spin on the shaft, it spins with the shaft. Because the flat obviously will stop it from spinning around on it. It spins with it, rather than on it. But if it spins on it, it's using the shaft as a kind of like a hub, but it's spinning on it. Anyway, that's the other side of the hour hand. And the back of the minute hand. It's quite hard to pick up. Cut my nails, so it's difficult not to do it this way. It's just polished metal. Not much to it really, just thin metal. This chrome dress strip, and that's the other one. And between that sits the glass, something like this. Glass fits in there, and the clock face in there, and that all fits onto this. And there's only 4 screws that sandwich all that together. Right, so that's that. This is just the back mechanism, the back plastic battery holder, electromagnetic coil, circuit board for the pendulum. That's the electric coil for the actual moving the hands, and I'm sure that will be responsible. And it'll pulse with the set frequency, based on the set frequency given by the accurate frequency from this quartz component. It's the hub for that runs through the centre of the clock. That goes through there as I showed earlier. This is a whole multitude of gears. Well, it's not loads, there's a few anyway. Acrylic gearing, and they'll all be, the number of teeth on them will deter the ratio. The teeth on the gears will deter how fast it spins. That's the back cover of the mechanism. That's a manual adjust, which has got a shaft on the other end with a gear bit, which will, if we could show that, it's going a bit out of focus. And you can see the spline on it, which will obviously mate up with the other gears so you can adjust the time manually. And there's these other contacts or whatever they do, I'm not sure what they are. And that's about it. That's about it. Now I've took still photos of it, so I think I'm going to just conclude the video with that. There's not much more I could take apart. What else is there to take apart? I think I've done everything. There's nothing else in here. It's just, that's it. Quite a lot when you see it in its elements. There's quite you know, you got wee fixture screws and you got all the wee components and the wee gears and everything. It's intricate. It's a piece of engineering. I mean, it's taken for granted. A lot of thought goes into it. Microchips, capacitors, printed circuit board, accurate gears. And I think, as I say, the second hand is the thing that does the clicking now, because this metal bit here was floating. I've lost my screwdriver. Yeah, that metal bit there was kind of, oh, that's magnetic. Ah, no. Huh. Well, that might have something to do with it as well then, because when this electro coil energises, it must then maybe pull this mechanism, this sort of roller thing on this mechanism here. These arms will allow this to swing back every second or something that will make this gear ratchet and pull mechanism work so it turns out. I don't know, but it's magnetic. I just discovered that there. So I'll be guessing, because that's a permanent magnet and this will be an electromagnet, that will energise within a certain time, and they'll use the base time frequency from the accuracy of the quartz component, because quartz vibrates at a very accurate frequency. That's why they use quartz. It keeps a steady time. So that's pretty much it. Oh, that's enough for this afternoon. I'm going to get other things done now. Tidy all this up and then get this video made and post it online for you. So I hope you enjoy it. So the next video will be the next video on my channel, but the next video regarding opening stuff up here on this pacing table at the back is here will be the electronic chessboard. And then after that, I can maybe go searching for other things and ask around and see if anybody's got anything they could donate. Ask my mates if they're going to be chucking anything out that's suitable to take apart for the video. So just stay tuned if you're interested. I don't know when I'll make them, but just when I get a chance. So it was quite interesting actually. I hope you found it interesting also. Anyway, just see what else I put on my channel, and thanks for watching. Okay, bye for now. See you later.